All right, ready to dive into the fascinating world of the periodic table? We're going way back for this one, exploring its history.
It really is incredible when you think about it.
It is
This chart, the one we all recognize, it represents centuries of trying to understand, like, what is the universe even made of?
more than just a classroom decoration, that's for sure.
Absolutely.
And speaking of going way back, we have to start with the ancient Greeks.
Okay.
They had their four elements, right? Earth, air, fire, and water.
Yeah. Seemed like a good theory at the time.
It makes sense, right?
It does, it does.
But as with many things in science, it turns out it's a little more complicated than that.
Yeah, they were definitely onto something, those ancient Greeks,
Mm-hmm.
observing the world around them, trying to find patterns.
Right.
But those four, they're not what we'd call true elements in the scientific sense today.
So how do we define a true element then? What are we talking about when we say element today?
A true element, think like gold or oxygen.
Mhm.
It's a pure substance. You can't break it down any further by chemical means.
Got it. So it's like the most basic building block you can have.
Exactly.
Which brings us to, I think, a really pivotal moment in our understanding of chemistry.
Okay.
Robert Boyle,
Ah,
in the 1600s.
big player.
He really challenged those old ideas, those classical notions.
He did. He really pushed the field forward.
It's almost like he hit, like, the reset button on chemistry in a lot of ways.
Absolutely. Boyle's work, it laid the groundwork for how we understand elements today.
So what was different about his approach? How did he change the game?
Well, for Boyle, it was all about experimentation.
Okay.
He was like, don't just take ancient texts as gospel truth. Let's get in the lab and see what's really going on.
He wanted to test it.
Exactly. He challenged scientists to think differently, to question assumptions.
Mm-hmm.
And that shift in thinking, that emphasis on experimentation, it was crucial for moving the field forward.
It's like he set the stage for everything that came after. But even with Boyle's breakthroughs, science still had some pretty wild theories floating around.
Oh, absolutely. There were still plenty of mysteries to unravel.
Like phlogiston.
Ah, yes, phlogiston.
What was that all about?
All right, so phlogiston, this was a theory that scientists were really into for a while,
Okay.
trying to explain why things burn.
Yeah. Makes sense.
They thought this substance, this phlogiston, was released during combustion.
Okay.
It was a valiant effort, really, trying to make sense of a fundamental process.
Right.
But as we know now, it didn't quite hold up.
It didn't.
No.
So what happened? What did they find out?
Well, the process of debunking phlogiston actually led to some major breakthroughs.
Oh, really? So sometimes being wrong can put you on the right path.
Exactly. It's like that saying, we learn more from our failures than our successes.
I like that.
And in this case, disproving the phlogiston theory paved the way for understanding something much more fundamental.
Which is?
Oxygen.
Oh, wow. So they were trying to figure out burning and stumbled upon a brand new element.
Precisely. Scientists were conducting all sorts of experiments, you see, trying to isolate this supposed phlogiston.
Mm-hmm.
And in the process, they started identifying these true elements, like oxygen.
That's amazing. So it's like one mystery solved led to another even bigger discovery.
Exactly. And as they discovered more and more of these true elements,
Right.
they started realizing something really important.
What's that?
They needed a way to organize all this new information, a way to make sense of it all.
It's like having all the pieces of a puzzle but no picture to follow.
That's a great way to put it. And so began the quest for a system, a way to categorize and arrange these elements in a meaningful way.
Because you can't just have a random list of elements, right? There has to be some logic to it.
Exactly. And several brilliant minds took on that challenge, trying to find patterns or relationships between the elements.
Okay, so who were some of these early pioneers of organization? What were they thinking?
Well, we had Johann Dobereiner, for one. He noticed something really interesting about certain groups of three elements.
What was it?
He called them triads. And get this, the properties of the middle element.
Yeah.
Often, they were like an average of the other two elements in the triad.
So kind of like a chemical Goldilocks situation?
Uh-huh. I like that. Finding the just right element in the middle.
And that was a helpful clue for organizing the elements.
It was a start. It showed that there were underlying relationships between these elements, that it wasn't all random.
So they were starting to see the patterns emerge.
Exactly.
Were there any other interesting attempts to organize the elements?
Oh, absolutely. Another intriguing one came from John Newlands.
Okay.
He arranged the elements by their atomic weight, and he noticed something peculiar.
What did he find?
It seemed like similar properties popped up every eighth element.
Every eighth. That's so specific.
I know, right? It's like clockwork almost. He called this the law of octaves, drawing a parallel to musical scales.
Hold on, musical scales. That's pretty creative, if not a little out there.
I know, right? It might seem strange, but Newlands was on to something big.
What do you mean?
He was picking up on this idea of recurring patterns within the elements.
And those recurring patterns would become hugely important, wouldn't they?
Oh, absolutely. They were like clues, pointing the way towards a deeper understanding of the elements and how they relate to one another.
Which brings us to, I think, the star of the show when it comes to the periodic table.
I think I know who you're going to say.
Dmitri Mendeleev.
The man, the myth, the legend.
He truly revolutionized chemistry with his periodic table.
He did. He really did.
What made his approach so different? How did he crack the code, so to speak?
Mendeleev's genius, it was twofold.
Okay.
First, he didn't just focus on atomic weight. He looked at the elements' properties too, how they behaved.
So he was looking at the bigger picture, not just one isolated factor.
Exactly. And here's where it gets really wild. Ready for this?
I'm on the edge of my seat.
He left gaps in his table.
Gaps, like he just left blank spaces.
He did. But it wasn't because he missed a spot or anything.
Why then?
He was predicting the existence of elements that hadn't even been discovered yet.
Are you serious? He was basically saying, I'm saving a spot for you, even though I don't know who you are yet.
Exactly. It was incredibly bold.
That's some serious confidence in your scientific theory.
And guess what?
What?
Those missing elements, they eventually showed up.
No way. So his predictions were actually right.
They were. Elements like gallium, scandium, germanium, they were all discovered later.
Wow.
And you know what's even more amazing?
What?
They fit perfectly into those empty spaces Mendeleev had left in his table.
That's incredible. We'll talk about a confirmation of your work.
It was a remarkable moment in scientific history, a true testament to Mendeleev's insight.
So he wasn't just organizing the elements we knew. He was providing a roadmap for future discoveries.
Exactly. But as with any good scientific theory, there's always more to uncover, always room for refinement.
You're telling me Mendeleev's table wasn't perfect?
Well, it was a monumental achievement, no doubt.
Right.
But even Mendeleev's brilliant mind couldn't account for everything.
What do you mean? What was missing?
There were still a few puzzles,
Okay.
little things that didn't quite line up.
So what was the missing piece? What did scientists discover next?
It all came down to something we call the atomic number.
The atomic number, right?
The key.
Okay, remind me, what is the atomic number again? It's one of those things I always feel like I should know.
It's easy to forget.
Right.
Basically, it's the number of protons in an atom's nucleus.
Protons, right, okay.
Think of it like an element's fingerprint.
I like that.
Each element, it has a unique atomic number. It's how we tell them apart.
Okay, that makes sense. So how did figuring out atomic numbers help them fix the periodic table?
Well, that's where Henry Moseley comes in.
Okay, another big name in chemistry.
The brilliant scientist.
Mm-hmm.
And he made this critical connection. He realized that if you arrange the elements by their atomic number...
Instead of just their weight.
Exactly. A lot of those little inconsistencies in Mendeleev's table, they just vanished.
Really? Just like that?
It was like finding the missing piece of the puzzle. Suddenly everything clicked into place.
Wow. So Moseley's discovery, that really solidified the power of the periodic table, didn't it?
It did. It showed just how fundamental those atomic numbers were.
It's amazing all these scientists building on each other's work.
Absolutely. That's how science progresses, right?
Right.
Each discovery builds on the last, leading to new insights, new questions.
And speaking of new questions, even with Moseley's discovery, the story of the periodic table doesn't end there, does it?
Oh, not even close. We have so many more elements now than they did back then.
We do, it's true.
And those discoveries, they led to even more refinements, really pushing the boundaries of the periodic table as we knew it.
So who do we have to thank for that? Whose discoveries really shook things up?
Well, one name definitely stands out. Glenn Seaborg.
Ah, Seaborg. I've heard that name.
Now, he wasn't just discovering new elements. He was like redesigning the whole periodic table as we know it.
Really? Redesigning it? How do you even begin to redesign something as important as the periodic table?
It was a bold move for sure, but he had a good reason.
What was it?
Seaborg, he was working with these elements called actinides.
Okay.
And he realized they didn't quite fit into the main body of the periodic table as it was structured.
So what did he do?
He proposed something radical. He said, let's move them
Move them. Where to?
to their own separate row. He created the structure that we see at the bottom of the periodic table today, that separate section.
Oh, right. I never really thought about it like that.
It was a big change. It really changed how we visualize and understand the relationships between the elements.
So Seaborg's kind of like the interior designer of the periodic table, rearranging things to make them flow better.
Uh-huh. I like that. And his renovations, they were more than just cosmetic.
What do you mean?
They were based on a deep understanding of electron configurations,
Oh.
the underlying principles that govern how the periodic table works.
So it wasn't just about making it look nice. It was about reflecting a deeper truth about these elements.
Precisely.
It's just incredible to me, that the periodic table isn't static. It's this dynamic thing that's always evolving.
It is. It's a testament to how much we're constantly learning about the universe.
And even with Seaborg's contributions, we're not done yet, are we?
You're right. The story doesn't end there.
Are we still adding to it today?
We are. The search for new elements, it's still going strong. Scientists are pushing the boundaries of what we thought was possible, creating new elements in laboratories.
Creating new elements. How is that even possible? It's like something out of science fiction.
It's pretty mind-blowing stuff.
It is.
They're basically smashing atoms together.
Smashing them.
Yeah, at incredibly high speeds.
Okay, and that creates a new element.
It can. It doesn't always last very long.
How long are we talking about?
Sometimes just fractions of a second.
Wow, that's incredible. But if it's only around for a fraction of a second, what can we even learn from it?
It's a challenge, for sure, but even those fleeting moments can teach us a lot.
Really?
Yeah, it's like getting a glimpse into the fundamental forces that govern the universe,
Okay, I can see that. Pushing the limits of what we understand.
Exactly. And it challenges us to rethink what's possible, what matter can do.
So what are they working on right now? What's the next big element on the horizon?
Right now, all eyes are on element 119.
119, what's so special about that one?
Well, if they can create it, and that's a big if,
Right.
it would mean adding a whole new row to the periodic table.
A whole new row. Has anything like that ever been done before?
Not yet. It would be a monumental achievement.
Wow. So what would that even look like? I mean, what kind of properties would elements in a new row have?
That's the million-dollar question, isn't it?
It is.
Each new element, especially one that starts a whole new row, it has the potential to change everything.
In what way?
We could see new materials with properties we've never encountered before.
Like what? Give me some examples.
Imagine super-efficient energy sources,
Okay.
or materials with incredible strength, things that could revolutionize engineering and technology.
It's mind-blowing to think about.
It really is. And there's this concept scientists are really excited about. It's called the island of stability.
The island of stability, what is that?
It's this theoretical region, right, beyond the current periodic table.
Okay.
And the idea is, in this region, super heavy elements might exist for much longer periods.
So not just fractions of a second.
Exactly. They might actually stick around long enough for us to really study them.
Or learn their secrets.
If we can reach this island, it could unlock a whole new chapter in chemistry and physics.
That's incredible. It makes you realize the periodic table, it's not just this static chart, is it?
Not at all.
It's this dynamic, ever-evolving representation of the elements that make up our universe.
It's a journey of discovery, and we're still figuring it all out.
It's amazing to me how it all connects,
It is, right?
From ancient Greek philosophers trying to make sense of the world
Yeah.
to today's scientists smashing atoms together in giant laboratories.
It's a story of human curiosity, this drive to understand what we're made of, how the universe works.
And it's a story that's still being written.
It is. The periodic table, it's a testament to that ongoing quest for knowledge. And with each new element, each new discovery, we get a little bit closer to unraveling the mysteries of the cosmos.
Well, I have to say, I've learned a lot today.
Me too. It's always exciting to talk about this stuff.
It is. And I think it's safe to say the next time I see a periodic table, I'm going to see it in a whole new light.
I think we all will.
To all our listeners, keep exploring, keep asking questions, and most importantly, never lose that sense of wonder because the universe is full of incredible things just waiting to be discovered.